Hey, ladies and gentlemen, today we're going to do Unit 7, Notes 2 on permutations. Okay, so the manager of a coffee shop needs to hire 2 employees, one to work the counter and one to work at the drive-through window. Katie, Bob, and Alicia all apply for the jobs. How many possible ways can the manager place them? So we have 3 people, but we have 2 positions that we're going to put them in. We have one to work the counter and one to work the drive-through. And we're going to make a list for these. So let's say that we choose Bob, or Katie and Bob. So Katie is going to work the counter and Bob is going to work the drive-through. Or I could choose those same 2 people and switch them, and Bob work the counter and Katie work the drive-through. Okay, so they are working 2 different positions here. Okay, so then I also could choose Katie and Alicia. So maybe Katie works the counter and Alicia works at the drive-through. Or I could flip that and say Alicia works the counter and Katie works the drive-through. So there are 2 ways that Katie could work the drive-through. One if Bob works the counter and one if Alicia works the counter. Then the last combination, or that's a bad choice of word, but the last grouping I could do would be Bob and Alicia. So maybe Bob works the counter and Alicia works the drive-through. Or flip-flop and Alicia works the counter and Bob works the drive-through. So how many different arrangements could we have? Well, here's 1, 2, 3, 4, 5, and 6. So there are 6 different ways that I could use those 3 employees at 2 different positions. Okay, and so this is the start of permutations. So a permutation is when a group of objects or people are arranged in a certain order. And it's important that that word arranged is underlined. And here, here we go. There we go. Order is important. AB is different from BA. So Katie working the counter and Bob working the window is different than Bob working at the counter and Katie working the drive-through window. So if you're still writing, go ahead and pause it and finish that up. All right, so how many different arrangements of the letters are there of the letters in the word triangle? So how many letters does the word triangle have? 1, 2, 3, 4, 5, 6, 7, 8 letters. So I have 8 possible spots. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I could put T in the first spot, R in the first, I, A, N, G, L, or E. So I have 8 choices that I could put in my first spot. But once I place a letter there, now that letter is no longer a choice for the next spot. So let's say that I put G there. So now I only have 7 more choices to choose from. Let's say that I plug N there. So I've used G and N. Now I only have 6. Then so on. 5, 4, 3, 2, and 1. So you want to go ahead and multiply all of those. And you should remember that this can be summarized as 8 factorial. That's from our 7-1 notes. So go ahead and do 8 factorial for me. So you should get 40,320 different ways that we can just rearrange the letters triangle. So let's say that we're going to still take those letters in triangle, except for this time the first letter automatically is an A. So 1, 2, 3, 4, 5, 6, 7, 8, and A has to be the first one. So there's only one A in there. So there's only one choice for my first position. But now after that, I have 7 choices because I've used 1. Then I have 6 choices, 5, 4, 3, 2, and 1. So in this case, I have 7 factorial. So go ahead and type in your calculator 7 times 6 times 5 times 4 times 3 times 2 times 1. In here, you'll find out that we end up with 5,040. That's a whole heck of a lot less than the 40,000 in the first one. All right. Okay, so then let's talk about license plates. So in Minnesota, license plates are made up of 6 characters, 3 letters or 3 numbers followed by 3 letters. How many different license plates can be made in the state of Minnesota? So we have 1, 2, 3. These are numbers. And then it's followed by 1, 2, 3 letters. Okay, now think about license plates you've seen, or maybe one of them off of a car that your family owns, is that the letters and the numbers can repeat. So it could have 777, okay, or 677, etc. So I'm talking about numbers 0 through 9. So 0 through 9 is 10 digits. So I have 10 possibilities for my first position, 10 for my next one, and 10 for my third one. Letters, we use all letters of the alphabet. So that means there are 26, 26, and 26. So go ahead and grab your handy dandy calculators and multiply all of those together. 10 times 10 times 10 times 26 times 26 times 26. You should get a rather large number for this. All right, we get 17,576,000 possibilities for license plates in Minnesota. And this does not even include all those custom license plates that anybody can have, okay? So just off the basic ones is over 7.5 million of them. All right, so go ahead and in the bottom box on the front side of the notes, write down the permutation formula. N is the total number of objects. R is the number of objects you're using. So you'll see the formula, or you'll see problems written out like that, and we're expected to use the following formula. N factorial over N minus R, and then that's in parentheses, and then the factorial. All right, pause it here to finish writing that. All right, so we're going to evaluate these. So this is on the top of the next page. I just have the formula written on the top for you if you want to jot that on the top of your paper too. So I'm going to plug these in. My N is 5 and my R is 3. So I have 5 factorial over 5 minus 3 factorial. So 5 minus 3 gives me a 2 factorial on the bottom. Notice the factorial is outside of the parentheses, so it sticks with that too. So I'm going to draw this out by hand. So 5 factorial is going to be 5 times 4 times 3 times 2 times 1 over 2 factorial, which is 2 times 1. Now you'll notice that I wrote the 2 and the 1 over the other 2 and 1 because those will cancel. So what I'm actually going to just do now is all I have to do is multiply 5 times 4 times 3. And we can actually do this without a calculator. 5 times 4 gives me 20. And then go ahead and take 20 times 3. Yeah, we get 60. All right, so let's go ahead and look at our next problem here. We have an N of 7 and an R of 2. So we have 7 factorial over 7 minus 2 factorial. So 7 minus 2 gives me 5. So I'm going to write it all out again. 7 times, oops, almost forgot 6, times 5 times 4 times 3 times 2 times 1, all over 5 times 4 times 3 times 2 times 1. And notice from 5 on down, all of that is going to cancel. So you're only left with taking 7 times 6. If you know your math facts, you've got that. If not, go ahead and type it into your calculator, 7 times 6. And we get 42. Right, so now let's put in using the formula into actually like a word problem. So it says there are 10 finalists in a figure skating competition. How many ways can gold, silver, and bronze medals be awarded? So gold, remember, is first place, bronze or silver is second, and bronze is third place. So we're placing them into a position. So my N is going to be 10. I have 10 total finalists, and my R is 3. I'm only picking 3 of them to put into first, second, and third position. So I have 10 factorial over 10 minus 3 factorial. So 10 minus 3 is going to turn into my 7. So I have 10 factorial, so 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Whoo, that was a lot, right? And then 7. 7 times 6 times 5 times 4 times 3 times 2 times 1. all of those are going to cancel. And so you're going to take 10 times 9 times 8. 10 times 9 times 8. You should get 720 different ways to award gold, silver, and bronze to those 10 finalists. All right, number 8 says a newspaper has 9 reporters to cover 4 stories. How many different ways can the reporters be assigned to cover these stories? Okay, so they have 9, that's our total, so that's our N. And we're going to put them in 4 stories, so that's our R. All right, I want you to pause it here and try and put that into the formula, and then try and simplify it, and then get me my answer. All right, hopefully you did that. Here's some work. Go ahead and check your work with mine. You end up with 9 times 8 times 7 times 6. So go ahead and do that into your calculator. So you should have 3,024 different ways that I can award 4 stories to 9 reporters. All right, and then our last one like this says, Miss Brisky asked a pair of students to read statements in Spanish and then translate them into English. So the first person reads it in Spanish, the second person translates it into English. If Miss Brisky chooses pairs from Jeff, Kathy, Chris, Anna, and Madison, how many different arrangements can she pair the students? So she has 5 kids, and she's going to pick 2 of them. Okay, so our N is 5, and our R is 2. Go ahead and pause the video here and see if you can go all the way through to get an answer for this one. All right, you should have ended up with 20 different pairings you can make from the 5 students. All right, so then we also sometimes have permutations with repetitions. And a lot of times this is saying you have this many things and I want you to just put them into an order. Specifically, we do this a lot with words. Okay, so here it says P and Q are alike, or P and Q are repetitions. There's always room to have more than just P and Q, and we're going to see that here in our next problem. So pause this so you can finish writing this down. So here, how many ways can the letters in the word Mississippi be arranged? So first we need to determine how many letters there are in Mississippi. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have 11 factorial, and then I have to put it over any repeats. So I have 1, 2, 3, 4 I's. So I have 4 factorial to represent my I's. And then I have 1, 2, 3, 4 S's, so 4 factorial to represent those. And then I have 1, 2 P's, so I have a 2 factorial there. Okay, so we're going to write this out and then we're going to simplify it. So we have 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Whoo! All right, all over. So 4 factorial. So 4 times 3 times 2 times 1. And then I have another 4 factorial. So 4 times 3 times 2 times 1. And then I have a 2 factorial. Ooh. So 2 times 1. So the first one is easy. I can cancel out all of those. But the next part is a little trickier. So what I'm going to look at is I have 3 times 2 here, which is the same thing as 6. So I'm going to cross those out with 6. And I have a 2 and a 4 here, and that's going to be the same thing as 8. So I'm going to cancel out my 8 and my 2 and 4. So what I'm left with is 11 times 10 times 9 times 7 times 5. Oops, I wrote 4. Times 5. Put a 5 in that last spot. Go ahead and grab that calculator and type that in. All right, you should be looking at 34,650 for a solution, or number of solutions, I should say. All right, last problem here. How many ways can the letters in the word geometry be arranged? So how many letters are in geometry? 1, 2, 3, 4, 5, 6, 7, 8. 8. Over how many repeats do we have? We have 2 E's, so 2 factorial. So we're going to do 8 times 7 times 6 times 5 times 4 times 3. And I'm not even going to write the 2 and the 1 because those technically cancel. So go ahead and multiply all of those out for me. All right. Did you get an answer? Did you get 20,160 possible arrangements that we could have? All right, go ahead, ladies and gentlemen, and complete your 7-2 worksheet to go with this.